Okay, I'm going to show you a proper way, a better way to charge a completely dead battery when you're down near 0 volts or 1 or 2 volts than is shown in other videos online. Most of the other videos online that I've seen recommend just hooking up another battery to your existing battery and charging it that way. But what's going to happen is your existing good battery is going to be up around 13 or 14 volts. Your dead battery is going to be around 0 volts. The difference between those two and the power delivering, the amperage delivering capacity of a new battery is going to mean you're going to draw a ton of amps, very high amperage into your new battery, which can damage the battery. There's a point that you have things called trickle chargers because it charges with a trickle, a very low amount of amperage, usually 5-10 amps or less. Slowly charging this battery up will help preserve it. Although if it's gone down that low, it's already going to be damaged a little bit, but you can try to keep it in a little better shape. So anyway, we've got a variable DC power supply. I currently have the voltage set to 0, very, very low, and the current you can see it's drawing is 0. I've got probes, jumper cables hooked up to these terminals here, and I have this separating the jumper cables so they don't accidentally touch, because once this thing starts getting charged up, of course it can deliver a lot of amperage, and if these were to touch after this battery got charged up for a day or so, or however long it's going to take to do this, you would get a lot of sparkage happening here, so that's no good. You want to keep those away from each other, and these ones obviously have a lot of copper exposed. So what I'm going to do is hook the negative up to negative. We'll hook the positive up. We might see a little spark here, even though it says 0 volts. It might be around 1 volt or so. Let's see. Nope, still drawing 0 current. So I'm going to turn up the fine adjustment here, and we're going to watch this current and see if it starts rising. We're going to probably want to put, I don't know, 2 or 3 amps through this. Okay, nothing yet so far, and it is on, so let's turn it up a little bit more on the course voltage. The way this works is the adjustment happens slowly. Okay, so we're starting to get some amperage coming in there, and you can see it's at like 1 volt or something, and it's already pulling half an amp. So let's bring it up to we'll go a little higher. It might be stuck right there. It might need to charge up a little bit more. I don't want to try to crank this voltage up too much. So basically what we're going to do is let it stabilize there. So what should start happening, you will know it's stable because the amperage will drop to 0 or close to 0, and the voltage will probably rise a little bit higher than it's currently at, although it's not going to get much higher. So right now we're charging it at a little over half an amp. I'm not sure how long that's going to take, but maybe a couple hours, 2 or 3 hours, something like that would be my guess. But we'll come back out here in a few hours and check. And again, once that amperage drops to 0 and the voltage stabilizes up a little bit higher than this, then we can turn the voltage up a little bit higher, and then the amperage will go back up. And you can see it's already coming down. So wow, that's actually happening quicker than I thought. That's great. And did the amperage or the voltage move a little bit? Maybe a tiny bit. So let's get this up a little bit more. And it is raining out here, so well, you know, I'm talking about the proper way to do this. It's a typical Seattle rainy day. But that should be fine. A little rain and electricity never hurt nobody, right? So let's turn up this voltage a little bit more. There we go. Back up to half an amp. Now we should get the voltage should creep up a little bit more. Yep, we're up to, what is that? That scale is pretty high. This power supply is pretty capable of delivering, you know, up to 150 volts, which is dope. So what is that? Maybe 7 or 8 volts? I don't have my multimeter out here to check, but it's probably something like that. So let's just sit here a while and see if that starts coming down. Again, we're waiting for the amperage to drop start dropping, that means, so what that means is that the voltage is equalizing out between the power supply voltage. We don't know exactly what it's at right now. Kirchhoff's voltage law, the voltage here and here is going to be the same. What the power supply is trying to deliver is probably around 6 or 7 volts. When this voltage equals out, so the 6, let's say this is trying to deliver 7 volts, but there's only 4 volts at that terminal. Again, I don't have my multimeter, so I'm not sure. When it dumps enough joules of enough amperage into this battery, then the voltage will equalize. So this will become 7, and that will become 7, and so nothing happens. There is no voltage potential across these leads, which means there is no current, because there's no voltage relative, between these two. And so when we see the current drop, we know that the voltage is equalized, and we can turn the voltage up a little higher. So then maybe we turn it up to 9 volts. And so now we have a voltage potential difference of 2 volts. And the current will start flowing again. And so we're just going to slowly keep doing this, creeping it up higher and higher, until we get to probably something like 8 or 9 volts, I'm guessing, will be enough for something like this. I have a NOCO in my garage somewhere, but this is a little C-Tech unit. I also have a battery tender. None of them will charge this battery. So we just want to get the voltage up high enough on this battery so that a battery tender or a trickle charger can take over from there and do its thing. I don't know how much voltage that needs. It's probably different on different units. Yeah, so this is taking a little longer, which makes sense. As the voltage gets higher, it's going to require a bit more time. So I will leave you here. But again, once that amperage starts dropping down again, you would start turning the voltage up a little more. Let's see if we can get a little bit higher. Yeah, it wants to top out there for some reason. I don't know. So I'm not going to try to do that. We'll just let it be happy there at half an amp. I don't know why it can't deliver higher than that. It should be able to, but oh, do I have current limiting? I bet I have current limiting. Does this power supply do current limiting? Turning it up, and the amperage is going down. Maybe that's because it's actually delivering more amps and it's starting to equalize. What do you want to bet? Okay, so let's try turning up. We don't want to go above. I wish this had a little bit better. Let's see what it's trying to deliver. So if we unplug this, it should show the voltage it's actually trying to deliver. Okay, so it's trying to deliver whatever that is. Each of those is going to be 5 volts, so yeah, maybe 8 or 9 volts. So let's hook this back up again. Current is down. Let's get it a tiny bit higher. So that is now delivering probably 11 volt. Well, it's not delivering 11 volts. It's charging at 11-ish volts, and it's delivering, again, about half an amp. So, okay, and that is starting to drop. Excellent. Okay, so what do you want to bet now? I didn't think it was going to be this quick. I'm going to disconnect. No, let's disconnect over here. Yep, that is the responsible way to do this. Disconnect over here, and then also disconnect over here. Okay, now turn the old power supply off. Sorry, this is a long video. I didn't think I was going to be able to do all of this in one video, but it looks like I should be able to get the trickle charger working now. Okay, so we got the C-Tech plugged back in. This was not working before. Take my word for it, it was not working. So plug in the negative to negative and positive to positive, obviously. And let's see if she's going to work now. Yep. So before what was happening is it just showed, just that. This light up here for battery charging was not on. It would not charge. And the voltage was 0.47 volts, half a volt. not enough for any charger to recognize. So we just slowly charged it up at, like, well, you can see there, about 1/2 amp. It's a very slow charge. Probably means that we saved a little bit of the life in this battery. And so now you can see it's charging, which it was not doing before. You'll have to trust me on that. Okay, so if you really want to nerd out and you have something like this, a variable DC power supply, you could also use those little DC power bricks and go up from, maybe, like, if you have one that does like 2 or 3 volts at a decent amperage, and 5 volts and 7 or 8 volts, and you could step them up that way. But you got to be careful the amperage you're pulling, because if you pull more than a few amps, your little DC brick is probably not going to be able to handle it. So these are great, especially if they have a decent current capacity. All right, 11 minutes. It's long enough. Aloha.